I think we can start with the second part. And in second part of our tutorial, so I will have actually also two subparts. So in the first one, I will show you how you can use MLflow for the whole machine learning lifecycle. So we will train models. So we will use some data set, do some data preparation, prepare our data, train the model, see how we can improve the model architecture, what we can do about it. And after that, we will compare our runs. We will see what we can do with these models and try to select the best one. So try to select the model we would like really to use in production, and then we will deploy it. So that's going to be the first part. And after that, I will show you how you can build the production pipeline with the MLflow. But now I think we can get started and dive into the first part. So in this tutorial, I will use ML runtime version 6.1 ML. So let me show you how you can create the cluster with this runtime. So in Community Edition, you can just go to Clusters, click on Create Cluster, select here 6.1 ML beta, and then can just create a cluster. Yeah, so in this part, I will use the lending club data. So it's a data source where we have different mortgages, and our task is to predict if the mortgage will be fully paid or not. So at first, we have here a couple of packages that we would like to import. Then we can read our data with Spark, and you can see the initial data set, how it looks like. So after that, we can do some data preparations, data manipulation, so we can use domain knowledge in order to create some custom features. For example, here I'm creating the feature bad loan. That's going to be our target column, the columns that we would like to predict. And then I'm going also to add a couple of other columns that I'm going to use as a features after that. So here you can see how the data set, the training set will look like. So here somewhere we will see our bad loan. Okay. And here I have my array where I will have all the columns that I will use as the predictors, and also as my target column. Then I'm going to convert my Spark data frame into pandas, and then I will use sklearn for that. Okay, and now we can see how we can use MLflow for tracking all the models. So we can start our run, and then within the run we can do the actual training. So we can create the sklearn classifier, we can feed the model, we can calculate some metrics, and we can evaluate them, and all this information we can store them to the MLflow. So I'm storing the whole model. Then I'm also storing all the parameters I have used for my classifier. And then I'm calculating a bunch of different metrics, and I'm going to store all these metrics to the MLflow as well. Additionally, you can store any other artifacts to MLflow, anything you would like to. For example, feature importance data, feature importance CSV file, you can also store it. You can maybe store some graphics, charts. All this is supported. So if we go to the MLflow run sidebar, you will see all the runs that we have. And if we just go into the MLflow UI, you will be able to see the actual parameters, so all the metrics and all the parameters that we have logged. Oh yeah, it's here. So here we can see the metrics, and here we can see the parameter. So in this case, I have logged the whole JSON. So now we can run our training function with different parameters. So in my case, we're using random forest, and we can specify the number of estimators. We can specify how big our trees should be. And then we can just run all this. We can run it a couple of times. And then, of course, for each run, we will get another line here. Okay, so with this approach, we have created our model. We have logged all this information, everything that comes with this to the MLflow. We can every time come back to the model that we have logged. We can reproduce the work we have done, but how we can improve this model, how we can maybe come up with the better model architecture, because if we take a look at the metrics, yeah, they're looking quite good, but maybe we would like to improve them even more. We can see that they're quite different. So this hyperparameters, they are really making a difference, and the model performance with each combination will be slightly different. So in order to do this, we can use hyperparameter optimization. It's a standard feature of sklearn. You can just do it using sklearn model selection package. But in this, if you do it just out of the box, it will take ages, because all these models, all the faults will be built and calculated on your one node. So here, with Spark sklearn package, you can do it in a distributed way. You can utilize the whole power of your cluster and like use each node for building some models. So that's exactly what I'm going to do here. So I'm going to use Spark sklearn package for my randomized search. In order to do this, I have to specify the search space. So here I'm specifying the parameters that this randomized search will use, and through all this parameter space, it will like search and try to find with the best model combination. So we can use, for example, lint space for the different number of estimators, and do the same stuff with the max steps. And then we can at the end generate the whole grid where we will have all these possible combinations of our parameters. And then we can just run the randomized search, and the only differences between this randomized search and the one that comes from sklearn is the first parameter SC. So it's a reference to the Spark context, and this will mean that Spark sklearn will distribute it over the whole cluster. And for example, in my case, building 120 models has taken just something about 4 minutes. In your case, in the case of the notebooks that we have provided to you that you can run on the community edition, I have used here slightly different parameters. It was not 120, it was just 20 runs, and the cross-validation was 2 and not 3. So you can run it. It will take maybe something about maybe 5-10 minutes, but it will work. And then we can get our best set of parameters, and we can also save them to the MLflow. So I'm doing it here. And after we have created the best, so we have found the best model architecture, the model that can give you the better performance. The question is, what model should we put to production? So we have now a couple of runs that we have done automatically. We have done a couple of runs that we have run manually. So now we would like to understand what exactly we would like to put to production, what model will it be, because here we have like really a bunch of them. And in order to do this, you can use MLflow client with Python client for MLflow. You can query all the runs. You can query the MLflow repository and get all these runs. So in my case, I'm going to at first calculate the path of my notebook and calculate my active experiment ID. So this is it. And then I can use Spark to get everything, get all the runs that correspond to our current experiment directly from Spark. And here in this table, you can see them. And this runs is going to be the standard Spark data frame. We can also run some queries, so use the whole like data frame API, SQL to query this data. So in my case, I'm trying to get the models with the ROC metric bigger than 0.7, and then I'm just interested in a couple of columns. And here you can see the results. And now we are coming to the most interesting part, how we can actually deploy this model. So in order to deploy the model with MLflow, we have to calculate the model URI. This model URI will contain the run ID, and the run ID it's the same string that in the previous tutorial was hard-coded. You can like also hard-code your run ID and just deploy the run you would like to, or you can try to get it automatically from the repository using some criteria. So in my case, I'm using criteria, so I'm going to get the run with the best value for the ROC metric. And then after I have my run ID, I can calculate this model URI. It's going to look like this. So it's the URI and then the name of the artifact. And after that, I can load my model from the MLflow. And I can run prediction. So here is the result. Okay, what else do we have here? So we can also, as I have mentioned before, we have query this, all these runs with the SQL. So in order to do this, we can create the temporary view. And then I can use SQL to get the runs with where we have the ROC metric bigger than 0.7. So like you can see them here. And after that, after we have selected our run and we have our model URI, we can also create pandas UDF directly from the MLflow. In order to do this, you can run the following column, the following row, and you will get the UDF that you can after that register with Spark and you can apply to your data frame. And that is exactly what we are going to do now. So I will create it as data frame. And here I'm going to apply my UDF to my data frame, and I will pass all the columns to the UDF because like it were my predictors. And here we will see somewhere the column with the name prediction. So it should be somewhere here. There is another possibility. What you can do, you can also use this. So run the model inference from the SQL. You can use the same UDF, and you can register this UDF within Spark as the function, and then you can use it from SQL, like this. And here we have our model call, and we can pass all our columns. There is, in order to really run the model in production, to apply to the production pipeline, you can do this. You can use the same technique. You can apply it to the streaming data. You can apply it to the batch data. You can use it together with the Spark streaming. For example, in this case, I'm reading Delta stream. And I have registered my Delta table as a streaming data frame, and then I can query this data frame with SQL and do the model inference on the fly. So this was the first part, and in the second part we will have a small exercise. So maybe Sander now will add a couple of things.
So for those who actually joined the first part, we talked about one of the big challenges in production is the silos between the data engineering, the data science, and the ML engineers. Partially this was due to different tools, and the breakdown was at the interfaces between the teams. What Michael's just shown is in a single notebook, he went through a lot, but the core pieces is we had a really big data set that was on Spark. He first took that data set as a Spark data frame, turned it into pandas, ran some basic pandas model, no need for Spark ML or the data scientist to actually use any Spark at all. But because that data scientist was using MLflow to log all of their pandas models, then when the machine learning engineer actually wanted to deploy, that machine learning engineer could then look at all of the results of all of the MLflow runs of that data scientist and then write some Spark code to say, select out the results with the highest given metric and serve that as a user-defined function back into Spark as part of our data pipelines. So even though it looked like he was going from Spark to pandas back to Spark, each of these pieces can be cut out between the teams. So Python sticks within the data scientists, data engineers and ML engineers stick with Spark, and yet the interfaces were extremely smooth. So that's the one part I wanted to just call out there.
And now in the second part, I would like to show how you can really put this together into the pipelines that you can use in production. So usually if you have different, let's say different data sources and different models, it's in some cases makes sense to update this model automatically. Let's say that you can get new data each day and you would like to check if it makes sense to retrain the model with this new data. So you can use MLflow exactly for this purpose. So you can track all the models in MLflow, and you can track all the metrics that you have there. And when you get this new data, you can just check if it makes sense to deploy the new model. And then in the pipelines which are consuming this model, you don't have to actually change these pipelines and change the code in order to get the newer version to production. You can automatically go to MLflow, check the latest version, so get the latest version from MLflow and use this model for inference. So that's the questions that we are going to try to answer now. So I will use the same data set for this part and the same models. So this is the code that you have seen already. So we can just skip it. And here I'm training a really simple logistic regression model. And I'm going also to log everything to MLflow. And then how are we going to track these production versions and the versions in MLflow? So in MLflow we have support for the tags. If we go here, oh no. I think at first we have to run it. So let's run this first part.
So while Michael's running, what we're going to see here in the second part is, again, the idea that in order to have a scalable production ML pipeline, you want to make sure that there aren't too many dependencies between the pieces and that the interfaces are clean. So in this case, we had talked about in the first session, business analysts being able to use models from the data science team purely via SQL. Now, what Michael will show in this section is even as the data scientists are pushing new models back to MLflow, because the SQL that grabs the models is just a function that says, give me the best model using this metric, the underlying SQL won't change. The data scientist will be pushing models, but to the analyst, they're just going to keep on using the SQL function, just noticing that for some reason, their SQL function just keeps on getting better and better.
So there is one more thing here. So when you set up MLflow, you can also define the experiment path, or you don't have actually to define it. If you don't define it on Databricks, you will so the experiment will be created automatically for you, and you will be able to see it here. But if you would like to have one experiment that a lot of people will be using in the same time, maybe you can use it from the different notebooks, as I'm going to do in this. Now you can set this MLflow experiment in this way. So I have trained my model. I think it should be ready by now. And then I'm going to deploy it. But let's now take a look how it looks in MLflow. So here are my experiments. So what actually I wanted to show you that we can set the tags to the experiment, and I'm setting in the code, I'm setting the tags prod equals true and the version. So and these two tags will be used after that to determine the version of the model. So now I have set these tags, and then in order to understand if we have to deploy it and how we can deploy it, we can calculate the version of the model. So here is the function that can get the latest, so the maximum version from the MLflow, and then we can deploy it. And the deployment is working really simple. We are getting this maximum version, and then we are logging the model with the version max +1. What else we can do? We can also try to check if it makes sense to deploy this newer model. So we can evaluate our current model. We can calculate some metrics. So in my case, I'm calculating accuracy, and we can compare our accuracy of our current model with the best model we have saved to MLflow. So that's exactly what we are going to do here. So I have my expression with the model name, and then I'm getting the best, so the biggest value for the rock metric. And then if our current rock is bigger than the one in MLflow, we just return true. And additionally, after that, you can do it in the way like at first evaluate if it makes sense to deploy it, and if yes, then we can just deploy the model. Now let's take a look at the consumer pipeline. So in consumer pipeline, we have to determine the most recent version of the model. And in order to do this, I have developed this function that uses Spark to access our MLflow repository and just gets you the max version. And then we can have another model, another function, something like getProd model, that can at first determine the run ID, the run ID with the biggest version, and then just construct the model URI and load this model from MLflow. And here we can use the same technique in order to get the UDF from MLflow. And then we can also register it as a Spark UDF and use it with streaming data, for example. So I think we have now a little bit time for the exercise. Yeah, so we have time for the exercise. So there are, in the document we have provided, there are links to both notebooks. And what you can do now, you can try to build another model. Maybe you can use random forest for that and try to deploy it on Community Edition. So you can here in the stream model pipeline just add another model and then use the provided functions like evaluate and deploy, and deploy this model, and then check in the consumer notebook if it's really used. Yeah. Do you want to ask a question? Oh, okay.
I don't manage to run the notebook. So it's got your name.
There is one thing that you should also change in order to make it up and running. So here, when we are setting up the experiment path, I have hard-coded my name. You can just hard-code your name, because this name just corresponds to the folder in the workspace. For people who joined just the second part of the session, here is the link to the document where you can find all the links to the notebooks.
Can you enlarge that? Because people in the back won't be able to read it.
Storage. Maybe.
I was in the last session, but I was at the back, so I didn't quite understand it. Once you've registered the model, as a UDF, how does the other user, the engineer or the digital developer, then use your model? So, what's going on here essentially?
Now it's like you have registered the UDF
Yeah.
as the SQL function, and then if you just go here, like look model, and then
So
there's a call.
Okay. So which part
It's,
is
it's like a SQL function. You know.
So the model is the SQL function.
Yeah. Okay, maybe it's not the best name, but you can maybe
Okay.
provide the like my
And then
favorite
this
model.
data is columns from the Delta Lake essentially table.
Yeah, exactly. The columns are coming from the data frame. It can be Delta Lake table, it can be anything else.
Does it have to be in SQL when you use
No.
the function? Can you use it as on
Yes, of course.
So you can use it on the normal Spark data frame as well.
Yes, I have shown.
Was it in?
I'll show it one more time.
Sorry, I missed it.
No problem. I can try. You want to task? Yeah.
Battery's about to run out. So I was going through your first one, right? So I did create an experiment, and I called it SK Learning.
Yes.
So I ran the steps,
Yes.
but I don't see anything in my experiment.
Yeah.
So
yeah.
I've missed.
Can you please go back?
Oh, sure.
And then can you please go? Yeah. Runs.
Very good.
And everybody is
There they
here.
are. Okay, so how come they're not on the landing page?
Yeah. Look, you can just like this.
Okay, so I was just.
And then you will see the same UI, but the thing is that when you like use MLflow in Notebook without setting this experiment data before, it will create this experiment associated with the notebook. But there is another possibility. You can just set the path, and then you can reuse this experiment from different notebooks and different like things.
I am new to MLflow, so that's
And that's like here you can see everything,
Yes.
or you can just set the path as I have done in this second notebook, and then you can like share it between maybe different notebooks.
Thank you.
So just checking, did you say that the UDF is slow on Spark Data Frame? You mentioned in the last one there was some...
No, it's not slow.
Okay, so it can be like instantaneous, real time.
So it's yeah, maybe in like not hard real time, like not a milliseconds, but if it's like couple of seconds and the data is coming, the UTF itself will not make a big difference.
Thank you so
Like
much.
it's like in with seconds.
Yeah. So actually, Michael, I see here. Is it on? Hello. So I just got a great question, and I wanted to mention this to everyone. So the question was, can we use this MLflow to check the model performance over time as the model is evolving or the underlying data set is evolving? And the answer is absolutely yes. You can do that directly through the MLflow tracking UI, or as Michael showed before, you can use the Spark connector to pull all the MLflow tracking data back into Databricks and analyze it as a Spark table. Now, the really killer use case that ends up here is actually detecting model drift. So everything that Michael just showed in order to do the hyperparameter optimization or to track the performance of different models turns out to be totally a great workflow for model drift over time. You simply have all your results coming out of MLflow back into a Spark table that you run from time to time as a job, and then that will check, okay, your model has dropped below some performance level, and then that can trigger a retrain, which will then once again send all the results back to MLflow, and the whole process starts once again automatically.
There are a couple of questions. If we can use the MLflow model, so if we can use it from the SQL, or if we can apply it using data frame transformation, so I can show this part. So here, for example, I'm reading the data. Oh no, here I'm reading the data from the delta table and creating the stream in data frame, and then I can apply the model to this streaming data frame directly from SQL. So model is the name of my UDF that I have registered. I have registered it here. I can give here any other name, and I can even register a couple of models as the UDFs, and then use them in the same SQL query. What else I can do? I can use the same UDF and apply this UDF to the data frame. In this case, you don't have to use SQL. You can apply this UDF to the data frame using data frame API. And here I'm creating the new column called prediction and passing all the columns from the data frame to this UDF. And here somewhere we will see this prediction column. Oh, it's here. And now I think we can go back to the solutions and to the pipeline. 5 minutes? Okay. And in order to create another model, so we can just at first do the start the MLflow run, and here we can create our random forest classifier, and then use our evaluate. And then we can use our eval and log metrics just to put them to MLflow, and then we can use our evaluate and deploy functions to put this model to production. So I can run this to cells. Oh, something went wrong. Oh, I have not defined the function. That's bad. Let's do it. now we have deployed the third version of our model. And now if we go back to the model consumer, and here we can run everything. And now you can see we are getting the random forest model and not the logistic regression from the MLflow. So what I have shown you, we have changed the model in the training pipeline. So we have trained the new version of model. So we have used completely different model architecture. And here in the consumer notebook, in the consumer pipeline, I have just run it without any changes, any code changes. This pipeline has just used the newer version of model. So you can use the same approach for putting all your models to production. So, any questions?
Does this mean that this should happen in our productive environment? So, does this mean that all of this should happen in our productive environment?
There are different ways you can approach this. You can have different environments for production and training or like development. But if you would like to directly deploy the models from training environment to production, you should use the same MLflow tracking server for that. But of course, you can do all the things in one environment and use just one MLflow tracking server and just use maybe different tags in order to differentiate between models. Like you can use maybe a model type, prod, stage, dev. Any other questions?
Does this include the new model registry that was announced today in the morning?
So, great question. Today in the morning, we have announced the model registry, and with model registry, you can do it even simpler and even easier. So now I have not used it, but with model registry, it will be even better.
So in model registry, I could essentially have those different environments, and then I could do the promotion to the production environment essentially because it would allow me to.
Yeah, exactly. So here I am using just a tag in order to designate, so differentiate between like production and non-production models. But with model registry, it will be you will have the UI support for that, and it will be just easier and more understandable. So it will be visible in UI. Now it's really tricky to get it in UI.
There is a UI to track what is the current model.
Pardon?
There is any UI to track what is the current model.
Yeah, you can. I can show it to you. You can use MLflow UI for that. So the question was how to now understand in UI which model is used in production. So we can go to our MLflow UI, and here we can just use MLflow query language. And here we can see our production models. So I'm just used the query language and filtered out only the models with tag prod equals to true.
Yeah, hi, thank you for the presentation. So I had a question on, let's say, Apache Arrow versus Koalas. So just to kind of clarify that it seems to be doing somewhat similar things, like converting Panda stuff to Spark stuff. What's your take on the difference between those two?
So Arrow, it's a format that actually we are using internally. All this Pandas UDF stuff uses Arrow because we are on the fly converting the Spark data frame, so partition-wise, partition after partition to Arrow, and then apply, and then the Pandas, then the Arrow is converted to Pandas, and then we can apply Python code to the Pandas. And Koalas, it's a great project that allows you to use Pandas syntax and to actually work with the Spark data frames. That is the difference. So like if you have Pandas code, you can use Koalas, and then under the covers, it will not use Pandas, but you will like leverage the whole power of your cluster. That is the difference.
Could you use koalas with ML?
Yeah, why not? Of course. Like, MLflow is not connected to any underlying technology. You can log any metrics. You can develop support for some other new machine learning libraries. So it's really open.
Okay, I think we've run over time, but thank you very much for coming. Hopefully you took away that in addition to MLflow being very easy for data scientists to just drop into their normal Python day-to-day code and get a lot of benefit out, it also allows teams to very easily move into production. I will actually be talking a little bit more on the theoretical side about when to use single node versus distributed models a little after 5. So please come to that, but I hope you enjoyed this tutorial. Thank you very much.
And thank you to our speakers, Michael and Thunder.